Welcome back to session 22. It is now our time to work with the calculator that we've developed for European swaptions. Let's remember that a swaption is an option granting the owner the right but not the obligation to enter into an underlying swap. Although options can be traded on a variety of swaps, the term swaption typically refers to options on interest rate swaps. There are two types of swaption contracts. A payer swaption gives the owner of the swaption the right to enter into a swap where they pay the fixed leg and receive the floating leg. In contrast, a receiver swaption gives the owner of the swaption the right to enter into a swap in which they will receive the fixed leg and pay the floating leg. In this section, we will present an interface to evaluate a payer swaption. In a typical swaption contract, the buyer and the seller have to agree on the premium or the price of the swaption, the length of the option, the terms of the underlying swap, including the notional amount, the fixed rate, and the benchmark, and finally, the frequency of observation of the floating leg of the swap. Now, in terms of some of its modalities, we can also talk about Bermudan swaptions, in which the owner is allowed to enter the swap on multiple specified dates. European swaptions, which are the subject of our exercise, in which the owner is allowed to enter the swap only on the expiration date, and American swaptions, in which the owner is allowed to enter the swap on any date that falls within a range of dates. In building our exercise, we've decided to set a benchmark and a stochastic process around that benchmark. The stochastic process we've chosen is the whole white algorithm because from the point of view of Maple has the advantage of handling term structures directly. We could think of other alternatives that, like the ones that we decide to use in our interest rate swap section, but we will leave that to the user. So now let's move down and find our interface. Like in any other case, if we look behind by right-clicking any of the buttons or any of the elements in the menus, we will see what the code looks like. For instance, here, the only thing we do is essentially load each one of the buttons. And we set some properties of some of the buttons that will then be used for our calculations. So let's look at this interface step by step. In the first part, first we start by loading information on several buttons, and we decide the type of calendar we're going to use. So we can use ISMA, ISDA, 360 or 365. We've already talked about these calendars in previous sections, so I will not go back to that. But if for some reason you want to take a look again at them, you can go back to the session where we dealt with the interest rate yield curve calculators. So we set an evaluation date. Again, we need to put these quote-unquote marks around these date formats. So start date, maturity date, and we need to click set in order to allow Maple know what the numbers are. Then let's look at the fixed leg schedule. We need to identify the calendar we're going to use. This is very important because that marks the days, the specific dates in which payments are made. And the frequency. So we're going to use a calendar which corresponds to EURIBOR and quarterly. So we set it. As for the schedule for the flexible, it has to be exactly the same as the one for the fixed leg. So we take EURIBOR and the quarterly. Now we need to set the reference for our interest rate model. So the first element is a forward curve. So what we will put in here are the rates of the zero curve, and these are the values, of the interest rates for the zero curve, and these are the dates or the times for which each one of these rates corresponds. So we have a node on year 0, 1/2, 1, 3, 5, 7, 10, and 30. So when we click set, the Maple calculator will get the spot rates corresponding to this curve. Now, we have now the need to set our benchmark rate, so what corresponds to the fixed component of the swap. So again, we choose what calendar will be used for that purpose, when the payments are made, and then we set. Finally, in just providing all the information needed to arrange the structure of the swap, we define the notional amount, the spread of the benchmark that will correspond to the flexible leg of the swap, and the interest rate of the fixed leg. So we have the benchmark, but we still don't have the model that describes the stochastic process of the interest rate. So we need to build upon our curve, our yield curve, the whole white model. As we know, there are two parameters, A and sigma. We've seen it in the previous session. And finally, we know how many steps we have per each one of the simulations. Notice that we are using a trinomial tree. Finally, once we've set the model, once we've set the parameters of the swap, now we can define what the fair rate of the swap is. And we can calibrate our strike as a proportion, or as a fraction, or as a as the result of multiplying the fair rate by a factor, and this factor will be k over fair, so we can toggle with it. Notice that we will create then the fixed and the flexible rates of the swaption by clicking this button, and finally, having all the information, we just click here and get the value of the swaption.